Hello, everyone. My name is Paulo Henrique. I am the commissioning editor at River Publishers. It is my pleasure to introduce this exclusive online book launch workshop for Revolutionizing Network Management, the Journey to AI-native Autonomy. This workshop will bring together the authors and participants to explore how artificial intelligence is reshaping the future of network management. This session will provide valuable insights into how AI can support advanced network operations, improve automations, and contribute to the evolution of future communication systems. I want to welcome here the author, Csaba Vulkán, from Nokia Bell Labs, Budapest in Hungary.
Yes, so my name is Csaba Vulkán. I'm a researcher and a research manager at Nokia Bell Labs in Hungary. And I have more than 20 years of experience on doing research on network management, optimization, and automation. My colleagues, because this book was written by three of us, Péter Szilágyi is my colleague at Nokia Bell Labs in my team. So we are working together in the same domain, whereas Nurit Sprecher, who is working for the standardization in Israel, she is a standard expert on network management. Well, this book is about actually answering the big question of how we can handle the technology, which is like, the technology is evolving with a very fast pace, and us humans are somewhat lagging behind on being able to be on top of it, master it, and use it to our benefit. And one very good example is the networking, where the networking technology is exponentially growing, expanding, and actually covering all aspects of our life. And because of this, we actually have to have meaningful and easy ways to handle this complex construct, which is the network, which is serving our, let's say, everyday communication needs. So that's the kind of the topic. And of course, as we are mostly, we see this kind of revolution of the technology from the early days of communication, when we had the circuit switch communication, traditional telecommunication technology, and we had an absolutely different technology, which was the IT technology or the internet technology. These were absolutely distant, separate technologies. And what we see that since the early 90s, these two technologies are converging together, and actually the IT technology or the web technology is kind of penetrating the mobile technology, and these two technologies becoming one. And this technology synergy is actually bringing in quite many changes in the way how we create and use mobile networks. One is that everything is becoming softwareized. The second is that everything becomes virtualized. And thirdly, that the AI technology is becoming a native part of the mobile technology, which actually brings in quite a lot of interesting technical questions, and also many benefits to the operators, to the service providers, and also to the regular users. Okay, so this is the context. I have a few slides, so I would like to walk through maybe into the book. So first of all, this is the book, and this is the table of content. I wouldn't read it out, just for you to know that the kind of the concept was that starting from the presentation of where the technology is and what are the key trends and catalysis in the system and the technology, then how that is evolving, and what are the kind of the evolutionary steps, and what are the components and ingredients of the AI-native autonomy and the AI-native autonomous systems. And actually, the structure of the book is following this logic that from the building blocks to the main enablers is actually building up the story, and at the end is kind of presenting the most advanced network management automation concept or paradigm, which is the network digital twin technology. And everything is actually enabled by the AI technology. And this is actually presenting my colleagues, my old co-authors. I was talking about them. I have introduced them, but actually the key motivation, again, a bit reiterating it, is that what we see today, that we have what we call a spiral of exposed complexity, which means that the technology is evolving and the different communication infrastructures are getting more and more complex. Sometimes different technologies like 2G, 3G, 4G, 5G is coexisting. We've seen the convergence of fixed internet services and mobile internet services, all kind of connecting not only households but also industries. They are used for providing services to different companies, logistic infrastructures, even national critical infrastructures and service providers. And this is actually one technology, the complexity trend. The other complexity trend that as these networks are becoming and technology becoming very ubiquitous, what we see is that there is a geographical complexity spreading around national. We are talking about national networks, spreading or giving coverage for the whole countries and even continents. Then we see a complexity which is coming from the way how what sort of applications and usages are kind of invented and introduced into top of the network. And also we see the complexity of the way how the users are moving, using the network, behaving through the network. And this is all is actually creating a very, very complex construct, to which actually the standard answer by the industry is that, okay, if something is complex, let us automate it a bit so that we can actually tame the complexity. And this is why early answer to the complexity was automation. And the first kind of automation tendencies were what we call self-organizing networks concept, where actually they were picking several specific things within a network for which they created targeted solutions. And actually that created some sort of automation silos within a network. But actually that was not solving the whole end-to-end automation problem and management problem, what these complex networks are kind of presenting. And we had to wait until the advent of AI and ML, machine learning, where actually the technology became so advanced that we could actually apply ML, machine learning methods, and also AI methods in order to automate, to do network management automation. And this is actually what is this is shown here, that this complexity is a spiral. It's always increasing, and this is bringing all the new technologies are bringing more and more complexities. The automation is also following this complexity and the additional complexity until the AI came, which actually changes the paradigm, introducing also the new kind of way how we can handle the technology. But as always, this also bringing in quite many additional problems. So the AI itself is bringing challenges in to the network management. And this book is actually also providing a walkthrough on how these kind of new challenges can be handled and managed by the network management automation itself. If I were to mention several kind of challenges, I would say one is that actually this is also yet another complexity and a different kind of complexity, because we need to be able to explain why AI mechanism did what it did, so the explainability problem. Then there is also other problem, which is the training problem, how we train our AI models in a complex network. Then the responsibility and the liability question, that who is responsible of the operation of AI, and then the management of the AI itself. So how we manage an AI or a set of AIs which is actually coexisting with our network. So these are the interesting questions which the book is exploring. But on the benefit side, and this is kind of the reason why the application of AI is very relevant here, is we kind of introducing the AI and applying it the proper way. Actually, we can break up these silos, so we can enable network to the systems to actually run in an autonomous way and to leverage all the capabilities what it has within in order to implement new and solve and handle new, let's say, management problems or management requests coming from the operator. That's one. And then it is also enabling the network to self-manage itself, so to be self-sufficient and self-efficient. And finally, with the advent of AI, especially with the advent of the large language models, and we can also use this one in order to interact with the system in an absolutely different way, which is the language-based interaction and language-based network management, which is absolutely a new paradigm, actually bringing absolutely new possibility to the way how humans can interact with not only with the networks, but in general with the technology. And this is, let's say, the second big thing what this book is kind of exploring, how this can be done, what are the main technological enablers, and how this can be introduced to the network management. Okay. Now going forward, just a bit going back to the book, other way of kind of presenting the content of the book is to kind of concentrate on three big technology areas, like you see here. So one very important part in any AI-driven network is that, of course, AI is using data. So the network management or any other software construct is working on data. So one very important technology is the network data exposure and control, that how we collect data, how we use the data, and how we expose the data either to the different network management algorithms or to the humans. And these questions are explored in three different chapters, which are building on on top of each other, exploring the data knowledge management, the data collection part in the network management, and then how this can be used and utilized and presented to the users through the interface between the humans and the network, and then how this can be further evolved with the language models and the LLMs. So that is one domain. The second is the native AI and automation. So how we can convert our systems from the current state where actually AI is kind of addition to the system, is kind of added to the existing networks, how we can internalize the AI technology into the system, how we can make systems which are natively AI-based, which absolutely brings benefits. And this explored in 6 chapters. I had to count them, starting from a new paradigm, which is the interface management, where actually the operator is not anymore going to the command line and entering commands and configuration of the system, but is just telling the network what it wants. I'm going to explore this one a bit later. And the network is able to interpret it and act upon that intent by itself. Then all the other ingredients for this kind of native AI operation. And then the third aspect is that, of course, like I said, the AI and the AI nativeness also bringing in additional kind of challenges, which are explored in the book. What I would actually highlight here is the security and trust issue. And for that, we have a separate chapter, which is kind of exploring the aspect of security, trust, and integrity of the AI-based network management. Very, very relevant and very important part of any AI-based network and management system and autonomous AI networks. These are structures. And then I would like to highlight two main and very interesting things in this podcast. One is the human perspective of autonomous system. I was talking about the complexity, that we have the topology complexity, we have the technology complexity, we have the geographical complexity, we have the diversity coming from different services. You can name how many services you are using, how many applications you are using. Each of them is actually behaving a bit differently. And not only that they are behaving differently at your device end, but also they are generating different traffic. They are having different service requirements from the system, which actually imposing different requirements how the system should kind of deal with them. Then also the demand for service, the behavior of the users, how they behave, how they consume the services, how they react to the poor service, how they change their behavior depending on how the service is serving them, and so on. And of course, this is always changing in time. This is not something static, but as the technology is evolving, new end devices are emerging, new applications becoming popular, then this is all kind of following that. And therefore, we cannot say that and sit, relax that, okay, now we've solved everything and we don't have anything to solve. But actually, we should create such a technology which is able to follow up by itself the evolution and the complexity evolution, and also the way how the system is consumed. And then this, like I said, the technology convergence and the technology evolution bringing in 3 very important things. One is the softwareization. So from common dedicated hardware, we have now common hardware, and we have everything softwareized on top of them. We have the automation as a main technology, and then the autonomization. Automation is not autonomization. Autonomization is something which is beyond autonomy, autonomous operation, because in autonomous operation, you have a logic which is executed in a cycle without human intervention. The autonomy is where the system is able to operate autonomously and solve different things by itself. That's autonomy. And that, of course, enabled by AI. And now, I also said that with the AI, we have these kind of problems like explainability, security, trust, liability, and other questions. And now the question is that given this very complex technology, even for a well-trained person, the main question is that how to interact with it. That's a very good question. That's one. The second question is that is from the human, that how the manifest should how the network should manifest itself to the operator. That's another question which the network automation has to answer. Then how to govern the autonomous network. So these are the, let's say, three very prominent questions. I'm not saying that these are the only questions, but these are very prominent questions which are actually I would like to highlight, and what I would like to kind of draw your attention as some questions which are well covered in the book. That's a book. Now, going forward, what we do today. So whenever you are sitting in front of a network, you are acting as a network operator, and you want to have to solve a problem. So what you do? First of all, you have a creative process where you formulate your goal. Yeah, that's a what. So what you want to do? For example, you want to introduce a new service. Then, because of your expertise and technology kind of tool set, you can create an execution plan. You can deduct that, okay, if you want to achieve your scope, then what you need to do and how you need to do in the network in order to make that happen. And of course, you can do this because you have a knowledge of the network, its capabilities, its status, resources, and everything. You master the tools, the management tools, and you are in position to do that one because you are a very trained network engineer, operation engineer, having all the skills and all the assets and tools enable you to do execute what you wanted to do. So actually to convert the what to how, and then to something which is actually happening in the network. And for that one, we used traditional interfaces, which was very complex. So command line interfaces, following step-by-step execution plans, or web-based interfaces, dialogues, whatever, was still very laborsome and failure-proof, prone kind of way of managing the system. And what the AI and what actually this new network management paradigm brings in is that some part of this kind of mental process is actually can be transferred to network. So introducing the concept of intent and enable network to work with the intent, actually you can transition and you can enable the network to take part of your mental process, cognitive process, and execute it by itself. And this is what this interface network management is bringing into the network. Because what we do and what is described in the book is that by making enabling network to operate on this new network management paradigm, interface network management, actually we are enabling the network to take in the intents defined by the operator. So basically doing this interface. Yeah. So this deductive part, the most boring part, which is more mechanical, is somewhat transferred and implemented in the system. And what the human needs to concentrate is to define the definition of the goals on the what part. And this is the interface network management, a well-known technology paradigm. But what we also describe in the book is that we can use a language interface instead of, let's say, some sort of syntactical interface to allow the operators to define the scope to network in a free text form. And this is the one paragraph in the book which is describing in detail how we can tell the network in a common English what the network is supposed to do, and how the network can take this in, do a semantic interpretation, and execute it. Okay. And of course, that means that we need to have semantic modeling of the network capabilities enabled by the AI and by the MML models and the agentic AI mechanisms, what is now available in the technology. And how this would work in a system. So how it would work is that we have this interface, what I define this simple textual interface, like a prompt. And we just define that, okay, what I want. So I want to have, let's say, a video service for, let's say, a football game for all the users who are visiting the stadium. Let's say 30,000 people visiting the football game should have a good video service on the area of the football stadium. So that is a very typical kind of intent. We define that one into interface of the system, and that is semantically modeled and interpreted by the system. And the system does a semantic matching based on its own semantic model, so enabled by AI, and actually finding the best capable solution, best possible solution, which can then personalize and offer to the operator as a part of the dialogue. So you kind of like go to a marketplace and say that, okay, I want this one, and the salesperson tells, okay, I have this one, and whether this is good for you or not, and then you start this kind of dialogue, and eventually, once you receive select what you want, then you actually can commit and accept the proposal. And then by saying that, you actually trigger the network to then work autonomously. And from that point of time, the network is responsible for the execution. And you as operator can define new objective, or you can just stay relaxed because the network is kind of doing its own part and actually implementing what you want it to as. Of course, there are limitations because not everything can be done. The network can only execute for which it has capabilities or for which it has resources. And the fourth aspect of this kind of interaction, or which is described in the book, is the way how the network can report back to you as a user, and how it can inform you on the status of the network, on the status of your intent, the success or unsuccessful execution intent, and even giving kind of reasons or why something was not working out, or why there was a failure, helping you to kind of do troubleshooting. And this is what we call natural language interface-based network management automation. Now, of course, this is only the part where you as the operator, a user, a human, can operate a very complex construct, and how AI is enabling network management automation. But what is happening under the hood is that if you consider that how automation, how network should operate itself, first of all, it has to collect a lot of data, like I discussed. And also sometimes it also makes sense not only to collect data of itself, but also collect environmental data, other data, which can be factored in for much efficient operation. Use this data for self-observation and self-learning, and also based on the learnings and the information extracted can trigger self-management actions. What can automated system kind of work with, or what are the tools the network can use for self-managing? For example, it can do automated resource allocation, orchestration, self-configuration, and self-optimization. And this is done in this kind of new network management paradigm described in the book, based on the very simple intents defined as kind of what I want as an operator to the network, and then the network is taking the action based on these intents, doing, of course, arbitration between different intents, detecting maybe conflicting intents which were defined, resolving the conflicts, or kind of bringing back the conflicts to the operator if the conflict cannot be resolved by the existing mechanism with the system. So this is one part what I wanted to be highlighted from the book. And the second thing is a new technology which is called network digital twin. And what is a digital twin? First of all, so the digital twin is a digital replica or virtual replica of an existing physical asset, a physical entity. In our case, a digital replica of a physical network. You can think of a network like a set of different radio base stations, optical links, routers, core network elements, terminals, and everything which is actually part of the network. And this real network, which can be digitized and modeled with digital twins, so we can actually, by collecting data information of network, we can use what we call representation and behavior modeling in order to describe and abstract its own the network's own behavior and state and operation in this kind of virtual domain. And why this is relevant? Because then we can have a much advanced service and network management, because we can use these models which we built in as a twin of the network to do different what-if analysis, impact analysis, optimization without disturbing and interrupting the network operation. And actually the output of model can be used for network and service management. It can enable much efficient network management automation, and of course can provide interfaces to the users, not only the internet interface and negotiation, what I was describing, but also feedback and reporting on the network states and the overall healthiness or status of the network. And as I said, it can be used to do different what-if analysis by kind of creating hypothetical scenarios and actually resulting in learnings to the operator, which then can also be turned as a actionable kind of recommendation, either automatically or by the operator for a new, let's say, introducing a new service or implementing a new capability into the network. So this is described in detail at the end of this book in the one of the last chapters, because this is one of the, let's say, the new technologies and paradigms which are I would say that are bringing a new way how networks can be managed. Okay, and how this evolved, maybe as a final kind of summary here, that how this evolved. So I was talking about the real system, the reality, and then the virtual realm where the modeling is done. And of course, at any point of time, ever since we had networks, we had models. First of all, we had queuing models, for example. We had fluid models of the network, where actually we had some hypotheses on the network behavior, and we created analytical models to describe it. These were mostly not relevant for the real network. They were mostly used for academic purposes or kind of collecting information and understanding the network, very much decoupled from the network. That was at the beginning of the network management automation. Of course, these network models were used in order to figure out different actions, but mostly the modeling accuracy and the validity of the modeling outputs and results were not that relevant for proper network management action. Then, as the technology evolved and we had more powerful models, we still had these decoupled models from the real network, but we started to be able to channelize and feed the models with network data, mostly offline, basically collecting data in the network side and with different means loading those data into the models themselves, which were doing simplification, and they could be run separately from the network. And of course, that allowed the long modeling cycles, not directly actionable items, but still a good understanding for the network management operation. Then, as we evolved, we started to have network management tools and models which were regularly updated and synchronized with network data, actually always refreshed with real network data, which maintained the model relevance incrementally. So whenever we were able to flush out some measurement data or network insight to the model was updated, and for the next flush or update, it could utilize that information, could be utilized the model with that information to do some operation relevant decisions and actions. And what Network Digital Twin is doing is actually closing the gap and actually enabling a complete symbiosis and a complete synchronization state between network and its model, allowing providing immediate and operational relevant information to the operator, and enabling close of automation and let's say real-time action or reaction capability to the network degradations or the different management challenges what the operator has to say. And this is the second thing what I wanted to kind of highlight from the book.
Okay, so thank you very much.